All right, moving into number 7. So this is the first real world type situation where you may see inverse variation. In a racing scenario, the time it takes to complete a go-kart course is inversely proportional to the average speed of the go-kart. One rider has an average speed of 73.7 feet per second and completes the course in 30 seconds. Another rider completes the course in 25 seconds. What was the average speed of the second rider? So as we read through this, the first thing hopefully you recognize is up here it said inversely proportional. Again, gonna basically mean the exact same thing as inverse variation, just different wording. So we want to identify where we see those words because before those words in that sentence is going to be our y value, in this case, time. After those words in that sentence, we see the average speed, which will be our x. So time is going to be our y, speed is going to be our x, and really with inverse, it's not as particular, which is which, because when you're multiplying the x and y value, you're going to get the same result regardless. So if I look at my initial information, we know that the first rider is traveling at 73.7 feet per second on average and completes in 30 seconds. So we'll use that information in our first equation to determine what k is. When we multiply there, we should get 2,211 for our value of k. Now, when we think about the context of that, if I take the speed times the time, that's going to give us the distance. So basically, this k value of 2,211 tells us that the go-kart course would be 2,211 feet long. So that's going to be the length of our course. If I then go and continue through the problem, we see that we have another rider who completes it in 25 seconds. Now, using maybe what you already know or using what inverse variation represents, if we have somebody who's completing the course in a quicker time or in less time, we know that the speed is going to have to be faster or greater than the first rider. So that's kind of important to know as we go to make sure that what we're getting as an answer really does make sense. So we start our equation. xy equals k using that new k value that we found of 2,211. We're going to input 25 for y into our second equation. And then we're going to solve for x by dividing by 25 on both sides. This one, the decimal does come out fairly nicely, so I'd say go ahead and leave it as a decimal. I'm going to get 88.44, and we are looking for a speed, so feet per second. You will also notice, as we talk about decimal here, our original speed was a decimal, so it'd definitely be a good idea to have this as a decimal. We could round it to the tenths place to match that original speed, but I think it's perfectly fine that we have that 88.44 feet per second.